Okay, hello everybody. Today I explain about the two crudos. I'm going to walk you through a Python project where I implemented face detection using two different techniques, Haar Cascade and MTCNN. The Haar Cascade is a classic computer vision method provided by OpenCV. The MTCNN is a deep learning-based method that uses convolutional neural networks. That is the same the name. We will explore both implementation step by step and compare their approach for detecting and cropping face from a batch of image. Okay, I start with the Haar Cascade. We start by importing the necessary libraries, uh, CP2, NumPy, Matplotlib, File, Timelab, Pandas, and TQDM. We define the input and output directories because these contain the folders. In this folder you can see, for example, the image. In this case is Albania. They have around 100 images with working that, but I only take 25 images. Okay, the next step is define the open directory, the folder for image with detected face outlined, create the folder if it don't exist, the folder for cropped face image, and create the folder if it don't exist. Okay, and then the we load the pre-trained Haar Cascade classifier provided by OpenCV. And, and now we define the face detection. I have here comments because I practice with another method. Okay, in this class of deep function theory, define the face detection function using Haar Cascade. In this part, it is the improvement. We can change and make the model maybe learn better. Sorry, I don't I don't forget the image. Okay, so the parameter is that we need is the image patch, the scale factor, the mean number, and mean size. The scale is to take the image size resulted at each image scale. The mean neighbors is how many neighbors each candidate rectangle should have to retain it, and mean size is the possible object size. So we detected the face in the image. If not face detected, we record the image in the path, iterate over the faces, and drag a rectangle around each face, crop the face region, define a name for the cropped face, and set the cropped face in the directory. Um, the next step is when then process a 25 image from the input directory. I know I can be use all image, but it's because the time. This is a daily project. You need to understand that I need time to prepare the image, the data. In this case, for example, um, we can see the image of the face is detected 101. It is a path because we have only in the image normally have two images. One image the ID card and little vote in the password. Okay. Finally, we display some of image uh, where no face were detected. In this case, no detector, no uh, without faces. Okay, okay, but maybe in this case is bad. Yeah, it's bad. In this case, for example, is a good crop. Bad, 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 good, good. Here, for example, this part the sign mm, it's a is a false is a false. And with yeah, chain with the MTCN face detector with deep learning. In this case, I we import the libraries. We define the input and output duration for this method is the same in this case, but here we select the MTCN detector because the library require to use the function to detect and process the face using MTC. We only need the path to the image because uh, this is a model. This is a model. It is a pre-trained model. What else? In the same case, we detected the face initial counter, and in this case, for example, this is better than the hearts. We process the same number of images. Finally, the report show images where no face were detected. For example, in this case, the model maybe don't understand the picture because it's I don't know how to say that in English, but in Spanish que es una posición different. It's a different position, and it's good. Okay, in this case, for example, yeah, it's a good model. For example, in this case, take the 25 image and 22 is a good model. Yeah. Mhm. Okay. This is the project that I worked today. The conclusion is the Haar Cascade is a fast but less accuracy, especially under poor light or complex angle. And MTCN is more reliable and precise thanks to its deep learning architecture, CNN and based. Both methods save annotated image with detection face holding photos, report face image for potential photo processing. This was an exploration of classical perceptive learning method for face detection. Thank you for watching. The quote today is something that said Michael Jordan. I had failed again and again throughout my life, and that is what I success. So thank you so much, and I hope you have a nice day. See you the next time. Bye bye.